Next transformation we're going to look at is a rotation. A rotation is a transformation that turns a figure counterclockwise around a fixed point called the center of rotation. Okay, so counterclockwise, just in case you guys don't remember, means normally a clock is going this way, in this direction. Counterclockwise means it's going backwards, so in this direction. So we're looking for a counterclockwise motion around a fixed single point called the center of rotation. So we'll use that in numbers 1 through 3. In number 1, we're going to first look for a fixed point, and so this could be our fixed point here. We want to see if this is able to rotate counterclockwise and become that in a fixed point. And it appears that this could rotate and become this figure. So this one would count as a rotation because it is able to rotate around this fixed point. Now, for number 2, we look for a fixed point, and we do have that. Then we want to see if this rotates counterclockwise. And it does appear to rotate, but the problem here is this lightning bolt looks dramatically bigger than this lightning bolt. So in this first one, the size didn't change, it just rotated. Here, it did rotate, but the size changed, and if the size changes, it is not considered a rotation. So this one would be no, because these are different sizes. All right, and then for number 3, we're trying to find a fixed point that this could rotate around. Well, these are not actually touching each other, so if I had a fixed point here, there's no way that I could rotate this small and it end up over here. This is actually looks like a translation, because if you take your points and slide them, it looks like they go up and to the right. So let's look at this on the coordinate plane. So number 1, we are looking at a rotation by 90 degrees about the origin. Now, the origin, just a recap, is this point 0, 0 right here. So we are rotating ABC right here around this point in this direction counterclockwise. So let's discover the rule. So we're going to figure out the points for A, B, and C. So A is 1, 1. B is 3, 4. And C is 5, 2. Now, let's write down our A prime, B prime, and C prime and see if we can find the pattern of how they change. So A prime is going to be -1, 1. B prime is going to be -4, 3. And C prime is going to be -2, 5. Now, if I'm comparing the original to the new, I had 1 and 1. Now I have -1 and 1. So I'm not really sure what the difference is there, so I'm going to look at this one. I have 3 and 4. Now I have -4 and 3. So it looks like these swapped, but this one's negative. So let's look at C as well. So I have 5, 2. And then I have -2, 5. So this one also, these swap, and the first one becomes negative. And so it's harder to see here, but these could be swapped, and the first one is negative. So it appears that our rule for rotating 90 degrees is going to be that we swap our X and Y, and the Y then becomes negative. These are rules that you're going to end up having to memorize, but I just wanted to show you how to find them. So let's look at rotating around the origin by 180 degrees. So let's go ahead and list our points for A, B, and C. A is going to be -4, 4. B is going to be -1, 4. And C is going to be 2, 0. Now, let's look at A prime, B prime, and C prime. A prime is going to be 4, -4. B prime is going to be 1, -4. And C prime is going to be -2, +2, 0. And this one actually up here is -2, 0. Okay, so let's compare these. So we have -4, 4. Now we have 4, -4. So those could have swapped. Let's look at B. We have -1 and 4, and 1 and -4. So these didn't swap. So it's not that they swapped, but I went from a -1 to a +1, and I went from +4 to -4. That changed there too. Let's look at this last one. So I went -2, 0 to +2, 0. So it appears, by looking at all these, that each sign changes when we rotate 180 degrees around the origin. So the rule for this one, for 180 degrees, would be -x, -y, because the negative is going to change the sign of whatever number is there. Okay, so let's just look at some coordinates now. But before we do that, you may want to write these down on note cards. So if we're rotating 90 degrees, the rule is going to be -yx. So we swap our x and our y, and we make y negative. Then for rotating 180 degrees, we're just going to make both things negative, or basically we change both signs. Whatever x was, we make it the opposite sign. Whatever y was, we make it the opposite sign. And then last, we didn't see an example of this, but rotation by 270 degrees. So what you do there is you, again, swap your x and y like you did for 90, but this time our x is going to change signs instead of our y. So we are going to use those rules to do a couple of these examples. So let's look at number 1 first. So number 1, we're rotating 90 degrees. So the rule is swap my x and y, make y negative. So my A prime, I'm going to swap 5 and -4. And then whatever my y was, which was 5, we're going to change that sign. So it's going to become -5. Okay? So B prime, again, I'm going to go ahead and highlight what I'm making negative. So the y is going to change to be negative. So we're swapping these two. This is becoming negative. So -5, 6. And then for C prime, we swap, make y negative. So it would be -1, -9. Okay. Now, let's try 270 since we haven't seen an example of this. So number 3, I'm going to go ahead for 270. we are changing the signs of the x this time. So I'm going to highlight my x's because that's what I changed the sign of. So for d prime, we're swapping these two, so negative 13, and then this becomes a negative 1. For e prime, we swap, so negative 9, and this negative 1 becomes a positive 1. And for f prime, we swap these, so I get a negative 2. And then 0, 0 can't be positive or negative, so it would just stay 0. Okay? Our next example is going to be number 7. So number 7 asks us to rotate the figure with the given vertices about the origin using the given angle of rotation. State the coordinates of the image, and then graph the pre-image and the image. So remember, our pre-image is our original A, B, and C. And then our image is our new coordinates. So whatever I'm going to get there. Now, we're rotating 90 degrees. So my rule for 90 is that I swap my y and my x, and I make y negative. So we're going to take this and we're going to write out our A prime, B prime, and C prime. So here I swap 3 and negative 2, and that actually becomes, let's go ahead and highlight, 3, 4, and 1 are going to change signs. So this would be negative 3, negative 2. For B prime, this would become negative 4, 3. And then for C prime, this becomes negative 1, 0. Okay? Now, I suggest you graph in different colors. So I'm going to graph A, B, and C first. So A is going to be at negative 2, 3. B is going to be at 3, 4. And C is going to be at 0, 1. So we're going to connect all of those. Now let's do A prime, B prime, and C prime. So A is at negative 3, negative 2. B is at negative 4, 3. And C is at negative 1, 0. Okay, so we rotated that around the origin, which is right here, 90 degrees. All right, let's try one more of this. So let's look at number 8. So number 8, we want to rotate it 180 degrees. And so the rule for 180 degrees is we're going to change the sign of x and change the sign of y. So let's rewrite our new coordinates. So A prime, all we're doing is changing signs, would be negative 2, negative 3. B prime would be negative 3, negative 3. And C prime would be negative 1, positive 2. Okay? So let's graph our pre-image. So 2, 3, 3, 3. And 1, -2. Okay, and then we're going to connect all of those. Now we're going to graph our image. So -2, 3. Sorry, -2, -3 is A prime. B prime is -3, -3. And C prime is -1, 2. We're going to connect those. Now, we rotated this counterclockwise around the origin, 180 degrees. Now, 180 degrees, we know that a line makes 180 degrees. If I go from one side of the line to the other, it makes 180 degrees. So we took this and basically completely turned it around. Now, if we kept going 360, it'd end up in exactly the same spot. But as you can see, we took this, and as we rotated it, it flipped over. All right. Now, let's look at your second note sheet. So what is important here is the formula to find the central angle. So to find the central angle, you're going to do 360 divided by n. Okay, and n is going to be the number of sides that we have. So let's look at this first example. It says regular pentagon ABCDE is divided into 5 congruent triangles. Find the image of each point for the given rotation. So we're going to take 360 and we are going to divide that by the number of sides. So if you go over here and count, or you just look at the fact that this is a pentagon, pentagon means 5. So you're going to take 360 and divide it by 5. Okay, so 360 divided by 5 gives us 72. Now, a central angle is in the very center of the figure. So this would be a central angle. This would be a central angle. This is a central angle. This is a central angle. And this is a central angle. So this tells me that each one of these angles is 72 degrees. And on your notes, you have that this point right here in the center is labeled Z. So, number 1 wants us to name the image of D for a 72 degrees rotation about Z. So if we start at D and we rotate it, remember we rotate counterclockwise 72 degrees. That means one whole angle hop. So if we go one whole angle hop, we end up on C. So the image would be point C. Okay. Let's look at another one. So number 2 says name the image of B. So we're going to start at B for a 216 rotation about Z. So what I need to do is figure out how many 72s give me 216. So if I do 216 divided by 72, that's going to give me 3. So I'm going to have to do 3 hops from here. And remember, we go counterclockwise. So we go 1, 2, 3, and we'd actually land at D. Okay? Hopefully y'all are getting this. So let's try number 3. So it says name the image of A. So we're going to start with A, or start at A for a 144-degree rotation. So I'm going to take that, divide it by 72 to 3. See how many hops I need. And that gives me 2. So from there, I'm going to rotate counterclockwise twice. So I'm going to make 2 hops. 1 and 2. So this is actually going to land me on D again. Okay. All right, let's try one more of these. So let's look at this non-agon right here. So non-agon means that there are 9 sides. So in order to know how to rotate this, we've got to figure out what each one of these angles are. So to figure out what each one of these angles are, we're going to take 360 and divide it by the number of sides, which is 9. When you divide 360 by 9, you get 40. So each one of these angles right here is going to be 40 degrees. So I'm not going to label them all because there's a whole lot, but I'm just going to write 40 on a few of them. So the first one asked me to name the image of I. So I'm going to start at I for a 200-degree rotation. So now to figure out how many times I have to go to get to 200, we're going to take 200 and divide it by 40, which is going to give us 5. So I've got to do 5 hops counterclockwise. So counterclockwise would be this way. So I'm going to go 1, 2, 3, 4, 5. And I land on D. Okay, now let's look at H. So we start at H. They want us to rotate it 240 degrees about W. And W you have labeled is this point right here. So I'm going to take 240, divide it by 40 so I know how many hops I need. That's going to give me 6. So I'm going to go 1, 2, 3, 4, 5, 6. And I'm actually going to land on B. All right, last one. We're starting with A, and we want an 80-degree rotation. So that's easy. 80 divided by 40 is 2. So we're going to hop twice, and we land on